Hello everyone. Today we are going to learn the composition and the classification of photovoltaic power generation systems, including off-grid photovoltaic power generation systems and grid-connected photovoltaic power generation systems. The solar photovoltaic power generation systems can be divided into two categories based on whether they are connected to the public grid or not. Firstly, the off-grid solar photovoltaic power generation systems refer to power generation systems that are not connected to the public grid and are usually used as power supply for portable devices to supply power to the areas or equipment far away from the public grid. Secondly, the grid-connected photovoltaic power generation systems are connected to the public grid and jointly undertake the power supply tasks. Solar photovoltaic power generation systems are the mainstream trend in the development of photovoltaic power generation technology today. The following is a study of the composition and working process of off-grid photovoltaic systems. The off-grid photovoltaic systems are mainly composed of solar photovoltaic modules, photovoltaic controllers, energy storage batteries, etc. If AC loads need to be supplied with power, an AC inverter is also configured. The most core component of the solar photovoltaic power generation systems is the solar cells, which mainly include monocrystalline silicon cells, polycrystalline silicon cells, amorphous silicon cells, etc. The silicon solar cells are commonly used. The single solar cells cannot be used as a separate power source. In applications, connecting solar cells into solar cell modules and installing them in series or parallel on brackets forms a solar cell array, which can meet the output power required by the load. The function of energy storage batteries is to store electrical energy, and it can supply power to the load at any time. It is divided into lead-acid batteries, nickel-cadmium batteries, etc. The most commonly used is the lead-acid batteries. The photovoltaic controller enables efficient, safe, and reliable operation of the solar cells and batteries, achieving the maximum efficiency and extending the service life of batteries. Inverters are devices that convert direct current into alternating current. As solar cells and batteries emit direct current, inverters are essential when the load is an alternating current load. In addition, they can also protect the system, such as effectively remove the effect of the output power of solar cells affected by weather. The working process of off-grid photovoltaic power generation system is that during the day, the sunlight shines on the solar cell modules to generate direct current. Part of the direct current is transmitted to the inverter through the controller and converted into alternating current for external power supply, while the other part charges the battery. When there is insufficient sunlight, the battery sends electricity to the inverter and is converted into alternating current through the inverter for external power supply. Next, let's learn the composition and working process of grid-connected photovoltaic systems. The grid-connected photovoltaic system mainly consists of photovoltaic arrays, lightning protection combiner boxes for photovoltaic arrays, DC lightning protection distribution cabinets, grid-connected inverters, AC distribution cabinets, etc. The photovoltaic array is a device that converts solar energy into electrical energy. The lightning protection junction box of the photovoltaic array can reduce the connection between the photovoltaic array and the inverter, making it easy for maintenance. It is installed between the photovoltaic array and the inverter. The DC lightning protection cabinet is to carry out the secondary confluence of the DC current output by the DC combiner box and then connect it to the inverter, which is mainly composed of DC input circuit breakers, lightning arrestor, anti-reverse diodes, and voltmeters, in addition to converting direct currents into alternating current. The grid-connected inverters also have tracking and protection functions, such as outputting current to suppress the harmonic currents and outputting the sine wave power sources to protect the public power grids. The common types of inverters include stringing inverters, centralized inverters, and microinverters. The AC distribution cabinet connects the AC power output from the inverters to the power grid through a circuit breaker and measures the electrical energy of the line, including the grid-side circuit breakers, lightning arresters, and AC voltage and current meters. The monitoring system monitoring the operation status of the entire power plant, the operation status of photovoltaic modules, the working status of the inverters, and the system's working voltage and current. The working principle of grid-connected photovoltaic power generation system. The photovoltaic array converts solar energy into direct current energy, which is then combined through a junction box after being further combined through a DC lightning protection distributed cabinet. It is converted into alternating current through an inverter. After being boosted by a transformer, it is connected to the public power grid.